Now on the screen, you can see the first page you get when you log in as an end user. After I sign in, we arrive at the self-service management console. In the top right corner, I can see my projects. For example, I select project 1. Here we can also see the location of the where we connected to. It shows Munich 01 right now. So right now, I'm working in the Edge Cloud environment in Munich. And the same experience applies across locations. At the account level, you can switch to another data center and use the exact same panel. Now, let's quickly walk through the menu. This is important because it shows how much you can manage by yourself without depending on the service provider. Monitoring. This section records everything that happens in your account. Who created a virtual machine, who shut it down, who attached a disk, who changed a security group rule. Every action is logged with a timestamp. This is very useful for auditing and history tracking. Alarms. Here you can create the alert rules. For example, if CPU usage goes above 80%, send an email notification. So you are not only monitoring, you are also getting proactive alerts. My profile and security. This is where you manage your access key and secret key. Since Zadara is compatible with AWS APIs, you can use these credentials with tools like Boto3, Terraform, or OpenTofu for automation. Compute. This is where you manage your virtual machines. You can create virtual machines, take snapshots, and configure autoscaling all from here. VPC networking. This is the networking layer. Just like AWS VPC, you manage your VPCs, subnets, gateways, elastic IPs, and security groups. And the overview screen also gives you a visual network map. Storage. Here you manage block storage, object storage, and snapshots. Load balancer. This is where you create and manage load balancers and target groups. Machine images. Here you can view existing images or create your own custom image. Certificates. This section is used to upload SS certificates for your load balancers. Protection groups. This is where snapshot and disaster recovery policies are defined. For example, which VMs are protected, when snapshots run, and where remote snapshots are sent, like from one site to another. So that was a quick overview of the panel. Now let's create a virtual machine together and then connect to it. I go to instances and click create. I name the server Windows Demo. The platform already includes many common images. For this example, I will select Windows Server 2022. Now we choose the instance size. Let's go with 4 CPU and 8 GB of RAM. Next is the key pair. On Windows, this key pair is used to securely retrieve the initial administrator password. On Linux, you can think of it like your SH key. Now this configuration. The boot disk is set to 50 gigabytes. If needed, we can add an extra disk right now or later after the virtual machine is running. For networking, we select the VPC and subnet. A default subnet is already selected. You can also use your own VLAN and subnet structure the same way. For now, I keep the default and click Finish. Now the virtual machine creation starts. Let's open the virtual machine and see what we can manage. Here we can what we see. Status, events, disks, network interface, monitoring, and snapshots. Also, we can see also important information such as the operating system image, CPU, RAM, and disk size. We also have a protection status indicator here. This means if a virtual machine not assigned to any protection group, it shows unprotected, which means no snapshot policy is active. Under events, we can see actions like VM created, including who did it and when. Under volumes, we see the attached disks and we can attach new ones anytime. Under networks, we see the network interface and we can attach multiple interfaces if needed. Under monitoring, we can see CPU, memory, and network metrics over time. Under snapshots, we can see local snapshots and if remote replication is enabled, remote snapshots as well. To access this server from the internet, we need to assign a public IP. I go to VPC networking and overview. This is like a visual network diagram for the project. I locate the Windows demo server and right click to it. Here we have many quick actions: stop, restart, VNC console, change CPU and RAM, extend disks, take snapshots, create alarm, and more. To enable external access, I choose Attach and Elastic IP. I select the interface, then I click the plus icon to allocate an Elastic IP from the pool. The moment I click OK, the Elastic IP is attached. The second critical step is security groups. Under VPC networking, I go to security groups. I select the default security group and click modify to view the rules. Outbound traffic is allowed. Inbound traffic allows port 3389, which is RDP. For this demo, it might look open to the public, but in production environments, you would restrict it to your office IP, trusted IP range, so only approved source can connect. Also, you can configure SL VPN. Now, we need to connect to this VM. I go back to instances and select Windows Demo and copy the Elastic IP. Then I'm opening my RDP connection. I paste Elastic IP, then connect. Username is the administrator. For retrieving password, we need to click More and Get Password. The platform asks me for the key pair file used during creation. I put my key file and click Next, and we got the password. After logging in, Windows completes the setup automatically and open the session. As you can see, creating a virtual machine and making it accessible is done in just few clicks. Now, let's show another self-service example. For example, attaching a disk. Let's say we suddenly need an extra disk space, maybe for logs, temporary backups, or quick data transfers. Without depending on the service provider, we can do this in minutes. In the volume section, I will click Attach. There isn't an existing volume ready, so I quickly create a new one. Size is, it could be maybe 75 gigabyte, and we click OK. OK again. The volume is created and attached to server. Now inside Windows, I will open disk management. I bring it offline the new disk, and I will initialize and create new volume. And now we will see the new drive under this PC. This demo proves something important. It's not only server creation. Operations like attaching a disk are also fully self-service and can be completed in just few minutes.